We're recording, so thank you all for being at the second seminar for veterinary biomechanics and surfaces. So our first speaker today is going to be Daniel Schmidt, who is a master's student in biosystems and ag engineering and a farrier and all kinds of other things. I'll let him tell you what he is, but he's going to talk quickly about some issues for frame rates and data for equine biomechanics.
Hey guys, so my name is Daniel Schmidt. I'm currently a master's student, but eventual PhD student. Like Dr. Peterson said, I am a farrier and own a farm and do a whole lot of other things that keep me busy in all of my free time. So this presentation is going to kind of go over a little pilot study that we did with a treadmill, looking at comparing IMU data, which is an inertial measurement unit, with some camera videography data that we got, and some issues that we ran into frame rates there, and kind of how we're going forward after that. Oh, hold on. There we go. All right. So just kind of an introduction of the, at least behind the scenes goal of the research project that I'm working on. Kind of the quote unquote gold standard for kinematic analysis is the use of videography. And there are some limitations with that. Primarily, you only have so much of a frame with a camera. And so you're usually kind of limited in either, if you're not on a treadmill, it's limited in the amount of strides that you can get. And then if you're on a treadmill, you can get as many strides as you want, but you're limited in the surface because you're stuck on that treadmill. And so we're looking at inertial measurement units. These are just kind of three kind of current commercial applications of them. I won't really go into that, but the goal is to take the data that we're getting from the IMU and compare it to the video analysis and say the sample rate that we're getting from the IMU is perfectly sufficient. We're getting the same data. We can just strap this to the horse and go running and go over any surface we want, any distance we want, and then get the data at a later point. So the material and methods on the IMU side of things for the treadmill data that I did, you see the little slam stick IMU attached to a bracket very securely with zip ties. So the data capture was the index, so it's the slam stick. And we're primarily looking at the gyroscopic data. And then data analysis, we're using MATLAB, a script that I wrote using the equations kind of listed there. The IMU spits out everything in quaternions. And so we have to change that into angular velocity, just so we can, comprehend it. Quaternions are a little abstract and hard. They're all matrix based. And so then I did some analysis in Excel. Let's see. So then video analysis is a little bit more straightforward. So we have the 2 points on the bracket. Can you guys see my cursor?
Yes.
Okay. So you have point 1 and point 2. And then to find the rate of an angle change, just did arctangent of the points differing from the horizontal. And to get those points, we used the MATLAB app called the Hendrix DLT DV8A app, and did some data cleaning. And one problem with the high-speed video, especially with the camera that we're using, the Sony RX100 camera, is that it does not provide a timestamp for the individual frames. So I have to go in and add that, add an assumed frame rate. Which we'll get into that a little bit later, but that led to some issues for us. So treadmill results, this is all just one stride. In the middle is the IMU data. This was analyzed with different equations, so it doesn't look as clean as it will in a couple of slides. But on the left, you have when I was comparing it, assuming the camera was collecting at 1,000 hertz. So our peaks looked really good, but our cycle length was, half of what we were getting from the IMU. And the IMU does provide timestamps, and there's ways to calibrate that and sync it with a computer. So that's relatively more reliable than me just inputting time steps. And so because of that, I went ahead and analyzed it at 500 hertz, and the magnitude dropped. And so there's a difference there, but our cycle length was relatively similar. And that magnitude length, I think it's in the next slides. Yeah. So this is on the left, you have our IMU data. And this is analyzed with the equations that I had at the beginning. And so it cleaned up our data a lot and also fixed kind of our magnitude problems. And so this is, the left is the IMU data fixed, and the right is the video, assuming 500 frames per second, even though the Sony was supposedly recording at 1,000 frames per second. And so that led us to look at some frame rate validation. The low cost version of it was doing slow motion video of me dropping that bracket, just dropping it straight down, and then picking the points. And the video analysis is still kind of noisy. So this graph is just the velocity of a single point per frame. And that's did a best fit line for that, just to as a form of like cleaning the data. And then to figure out, what frame rate we were recording at, I took the slope and then acceleration due to gravity, and found that. And this one was after clearing the camera card. We ended up getting 717 frames per second. Before I cleared the card, it was right around 450, which was kind of what I was seeing in that initial treadmill testing. So next steps, basically Dr. Gillette's going to give us some nicer cameras, and the Sony might be left behind. I still have some things that I want to try. I have a different card that I'm going to put in, and just see if I can get that frame rate up and maybe find a way to make it more reliable. But Dr. Gillette has the iSpeed camera for us, which is going to be perpendicular to the path of travel of the horse in the final testing. And then we have the Fast Tech troubleshooter, which is going to provide a head-on view. So hopefully we can get some different looks and more of a 3D view of that. And then we'll have 2 GoPros running as well, which will be much slower frame rate, but will be able to give us the whole picture, because we are limited in the amount of time that these cameras can record at these higher frame rates. And then these are 2 screen grabs, just at the 0 points on the graph. So as the angle changes, just they look kind of cool. And that's down here is you have negative 67 degrees and 18 degrees in terms of how my foot is with the horizontal. But I'm happy to take any questions or any recommendations for ways to try and validate frame rates. I'm all ears for it.
So I got a few of them. So at best you got that the camera said 1,000, but it was still really only 700. Is that correct?
That was the highest that I've been able to get so far, is the 700. The camera SD card we're using is a micro SD card, and it's in an adapter. So my next thought is of just using a SD card without an adapter, in the thoughts that maybe the adapter is slowing us down.
I think what's good, unfortunately for all of us, is that's a great example of what's stated as frame rates in a lot of these production items and what reality is and how we really need to watch that. But along those same lines, when you presented that, these are things I've run into in the past. You talked about you clean data, and you talked about noisy data. Sometimes when I've cleaned data, early in my time I clean it to a point that I actually lose significant information. Do you have a way to say, okay, I can clean it this much without losing something, or how do you approach
So
that?
when I did it before, and I can hold on, I'll pull up a.
Yeah, you don't have to go too in depth on it, other than if you are doing that, that's great. I mean, if you've got ways to show that.
So the MATLAB app has a way to visualize it as you're kind of cleaning that data up.
When you talk cleaning, you're talking about the IMU data?
This is video data that I'm about to show. You guys see that?
Yes.
I can.
Yeah, so this is a screen grab from cleaning up the video data. And so that faint blue line you can see is the input data, and that blue is the smooth data. So that's at least a visual way. Just because this initial pilot run was for a class project, and so this is just kind of a quick and dirty way of doing it.
All right.
But I'm not losing a whole lot of peaks. And the biggest thing for me is we're not getting time stepped off of that. You know, it's all lining up. We're losing some data at the peak, but our overall is matched, so we're not being offset.
I don't mean to knock my profession, but sometimes I'll be at a veterinary meeting and they'll describe something, and I either will ask them, what was your capture rate, or what was your Butterworth filter set at, and they have no idea what it is. They don't know what their rate was or anything. And and sometimes some of us, when we open our mouth, expose things, and that's why I thought I'd bring that up.
Yeah.
So you see what McKinsey's done with her acoustic data. That's exactly a case of that, because we just oversampled it, because the frequencies that horses can hear are quite a bit wider than the frequency range is quite a bit wider than humans.
That's cool.
Yeah.
Right.
Yeah, I definitely ran into similar things, even just trying to find justifications for my sort of validation, especially on the frame rate, has been tough. You know,
It is. Yeah, I ran into that myself. Yeah.
Yeah, if I can find somebody that's done it before, I'm happy to do it that way, but I haven't quite yet, and especially in a low cost, way. I found a big giant military document about it, but they have a bigger budget than us. So
Yeah.
Thanks, Daniel.
Yeah.
So our next speaker is Rob Gillette. Rob received a veterinary degree in 1988 from Kansas State, but the reason we've got him here, because there's all kinds of veterinarians we could talk to, but Rob did something a little different. That he did a postdoc in kinesiology and a minor in exercise physiology at the Human Performance Program at University of Kansas, and got a master's of science education. He then, when I first met him, he was at Auburn, and he was director of the veterinary sports medicine program. Since then, he's been in private practice and in several other positions. And he has the entire time maintained this consultancy of Sports Vet, where he worked with a number of different people with Canine Biomechanics. So Rob, the best thing that Rob did for me was he introduced me to mushing, and it was fortunate they did it late enough in life that I had a job and kids. Otherwise, I'd have been somebody, shooting moose and taking big hunks of meat out and boiling it for the dogs for the rest of my life. But that was late enough that I avoided that end. So, Rob, thanks.
No problem. Appreciate it, Mick. The topic is very wide, and really you really can't cover Canine Biomechanics, known or unsolved problems, within 2 or 3 years' time. So I thought I'd try to keep it within a half hour, and that I might focus more on surface impact factors and their relevance to canine conditioning and rehabilitation programs. That said, I got introduced to this topic when we were trying to identify ways to improve racing safety, much as Mick was back in his day, or is still going today, but that's how we got introduced to each other. And I was definitely not an engineer, and learned so much from him and everybody that we've worked through over the time. So I thought I'd just go in a little bit of what we deal with on a surface standpoint from the dog side. So as I said, it's very wide and diverse. If we want to provide conditioning programs and environments, we got to understand how things happen from a physical standpoint. And I've done a lot of different things to try to identify that. But it's interesting because really, when we talk about lameness in dogs, or we talk about performance in dogs, or we talk about locomotion in dogs, or even anatomy, there's just no real information out there on what happens when the paw hits the ground, or when we get surface impact. And I did a quick search before I got on here and found 4 articles. One of them was our article we did back in 2012. And so it really shows how there is unsolved problems. There's a lot there that we don't even know what to go after just at this time. So it's an area that if anybody has an interest, really could take it places. So some examples of dog events and tasks. I know, a lot of times we focus on the racing surface, and certainly I did a lot of that with the racing greyhounds, but obviously every dog that walks around comes to contact with some sort of surface. That said, that every dog that performs their task needs some sort of benefit or some way we can understand how that paw to surface interactions. So there's a couple pictures there of our detection dogs, and you can see they're actually working indoors on tile or marble surfaces. Obviously, not much we can do about that. Herding dogs, in a grassy area, sled dogs in snow and sometimes not snow. A lot of times there's no snow around. And then we have dogs like the pointing breeds and the retrievers. So what are some of the surfaces that these guys interact with? Well, you get all kinds of either rocky, hard surfaces, you get grass surfaces, you get gravel, you get sand, you get all kinds of different surfaces. And the picture, when I'm looking at it, second from the top there next to the soldiers, there's a dog. He goes out on the road to pick up the bumper, but when he comes back, he runs in the grass. So that's a selective nature of that dog to identify a surface that apparently it feels more comfortable with. I think that's interesting. Most people don't really pick that up, but and a lot of dogs don't care. But then on the bottom row, it really even filters into veterinary rehabilitation, is what's the home environment that the dog has to go into? Are we dealing with a tiled surface, hardwood? Are we dealing with carpet or some sort of surface that they can get some grip on? And then obviously, the treadmills are starting to get to be used more often now for exercising of dogs, and that can also play a role. That said, that's the surface part of it, but now we're talking about the animal component of it. There we actually see 2 different paws. One on the far right's a greyhound. One on the left there is a sled dog paw. The 2 pictures on the right are the palmar surface of that paw. The picture on the far left is the dorsal surface of the paw. And why I bring that up is, one, you obviously to see there's differences between the dog makeup and the dog design. But there's also a big difference where we have pads on the bottom and no pads anywhere else in the body. And people forget about that. The paws are really designed to interact barefoot onto any type of surface there is out there. And you forget how good they protect things until you see a dog that comes in, that got hit by something and got dragged on asphalt where the skin was ripped off. So I used to do I spent 3 years in reconstructive surgery and wound healing, and animals that lost their pads really didn't have a way to protect themselves. So it even adds more to the importance of the pod to surface interaction. So we got to start here with say a greyhound, and our goal was to design a racing surface around that would best be able to handle the impacts and the forces needed to allow a greyhound to run throughout a race and minimize the risk of injury or damage related to that race. So when we were designing that or working on that surface, and we realized that and you guys may know all this, but in a sense, from a impact standpoint, the surface has two layers. There's a part of the surface where the paw actually enters the racing surface. Then at some point it stops and gets traction. So we have an absorptive layer and a traction layer. And the contents of the surface, management of those contents, the weather around that surface all play a role in those two layers and how they're formed throughout the racing surface. This slide's probably a little hard to see, but I did some work back in 89 or 90 with the National Geographic related to greyhounds and running. And I just happened to capture some of these frames where they had a camera running next to the greyhound. And the paws comes out and extends forward. And then you see it actually enter the surface. But what always intrigued me about this, and I later found out it's not just the greyhound, it's other breeds as well. And I think you might be able to pick it up in a video I got to show here in a bit, is that the extensors of the digital extensors actually are extended prior to impact on the surface. So it wasn't like it hit the surface and then spread the paw apart. They were extended out before they even hit the surface. And that was kind of an eye-opener to someone like me. So then we talk about the surface content. In the greyhound world, the surface is usually composed of a sand, silt, clay, and water. Now, these slides are from probably 1993. So now we're talking 30 some years ago. So the racing surfaces around the world might be different. And of course, there's only one state now that really races greyhounds in the United States anymore. That's up in West Virginia. But that said, it's very similar to what you deal with in the horse world. You can have wet tracks, you can have a dry track, or you can have a dry track with low sand content, all these different variants, and they all play a role in how the paw hits the surface or the role in the interaction. We used to use a lot of racing injuries to determine what's going on with the surface. That's really after the fact, and we always, and our goal at that time was to try and identify ways to prevent them and use track measurements instead of the injury surveys. You know, certainly a hard track is get the impact is going to have a toe, a metacarpal, carpal issues. A soft track, a lot of times you'll see shoulder, muscle, or traumatic injuries. But the one we saw more often than not was an inconsistent track, which had an accumulation of any one of those types of injuries. When we saw the presentation last week, it was really fun to see that because, and you guys have probably all seen this before, this was the old triangle we used to use to determine what our tracks are going to be made up and how to best manage a track. I just kind of threw that in there for old timer's sake. But when we think about it, surface contact, stability is a basis core because the rest of your locomotory actions is based upon that. If you don't have a good solid contact, then the rest of the body is now using forces or creating energy in muscles and tendons that's really unneeded or unprepared for in the body. And so you want to make sure you have good contact stability for the locomotory actions to occur. So I thought I might mention a little bit about the step cycles. It's a quadruped, much like the horse. The only real difference, well, there's a lot of differences. Obviously, one of them is that the paw has 4 digits as opposed to a hoof, which is more of a solid type of object. But the cycle is made up of a stance phase and a swing phase. The stance phase is there's a point where the paw touches down, that there's weight transfer, and then there's a push off. And then there's an initial rearward swing, a forward swing, and a final rearward swing until the paw comes down again. So this is my thoughts as how an engineer sees this. The yellow dot is a center of mass or center of gravity. The GIF on the right is front limb movement, and the GIF on the left is rear limb movement and how it goes through its cycle. The first time I saw one of these, Mick had showed it to me. I was like, that doesn't describe it at all. But in reality, it does. I just didn't get it at the time because I didn't understand how this works. This is how I see it. I've got on the right is the front limb, on the left is the rear limb. That I've got all these different components within there. And from a mechanical standpoint, I totally now understand, as of 25 years ago, what that's about. But from a conditioning or medical or rehab standpoint, I also have to understand the components of that lever arm that comes through. So if we think about the surface impact and the forces involved, you have force absorption and then you have surface traction. So if I have in this case, and I apologize for my numbers here, there's a 70-pound greyhound traveling at 40 miles per hour. As it comes down, it's going to land on that front leg about 2.25 times body weight. And then there is a certain friction value that's going to be needed so that it doesn't slide frontwards, backwards to the right or to the left. And that's how we came up with this 4.047. So sure, that front limb is absorbing this, but because the complexity of the front limb of the dog versus the horse, you also have to now to determine intra-paw forces to understand how each of the digits are receiving this. So to help understand that, if we think of where the center of gravity of the dog is, it's just behind the shoulder blade, mid-chest. So when that comes down, you're going to get compressive forces on the medial aspect, distractive forces on the lateral aspect of the limb, and you're going to get a rotation around that limb. To offset that, the quadruped or the dog will move as they're going forward. Their limb goes towards center line or midline, which affects how the paw and how the distal limb impacts the surface. So I don't know if you can see this, but this is a video of an Aussie that is running towards the camera. So he's running, and then at some point he actually slows down. But it really shows how the front limb, this is a normal dog, the front limb crosses over midline. Then as it comes down, you see this kind of rotational effect on the paw itself. I saw a lot of reports in the literature about how forces affect the paw. And I always noticed that it seemed that digit 5 had the first, or the initial 5 and 4 would have the initial impact, followed by 3 and 2, 1 being the dew claw on the dog. And so, but no one really ever talked about that because they said the forces were usually in 3 and 4. I think going back to capture rate, that makes a big difference, because if you capture at 200 hertz, you may not actually pick up what's happening to the forces because they're happening in between your capture times. So this video here was captured at 2,000 frames per second. And so you're able to identify a lot more things that occur during that action. So like I said, you have compressive forces on the front aspect of the limb. You have distractive forces on the caudal aspect of the limb. You have compressive forces on the medial aspect and distractive forces on the lateral aspect. So a lot of your extra forces on the limb as they come down are actually going to be your palmar or plantar and a lateral aspect, kind of right around in the front leg, right around where the accessory carpal bone is and those structures, and then the tarsal bones in the rear limb. So these forces aren't just happening at one time, they're happening over time. So you have a Z force that goes straight up the limb. You also have a medial lateral force or an X force, and then a fore and aft craniocaudal force, which is the Y force. But because it's happening over time, you're also going to get rotational torsional forces, where you'll get what we define anatomically as supination or pronation. So this was captured at 1,000 frames per second. Now the other film was captured outside in the sun, and light is huge when you're capturing at these high frame rates. But this is a nice image of Augusta where the paw's coming down. You can see the pressures on the pads, and as it goes across the paw pad as it impacts. And obviously, this is on a pressure mat, so it's a hard surface. It's not a soft surface. And even though the paw is not moving now, there are all kinds of forces happening inside that paw. as the tendons stretch, the ligaments are strained, the joints go through their different actions. And so often in veterinary medicine, we talk about the bones and the joints, but we don't really talk about the ligaments, the tendons, and the muscles that are attached to those tendons. So if I can't develop a surface if I can't control the surface that our military dogs are going to go into, I then have to adapt or prepare the dog for those types of surfaces and those types of environments. And so understanding how that happens is important so that I can identify or plan ways to prepare the dogs for these areas. The other thing I really haven't mentioned in the previous slides, but the pad plays a huge role in this, and that it's very important in accepting the forces that the paw gets, or each digit gets as it hits the surface. It actually plays a role in the spring effect, but a lot of times we don't talk about it until you talk to a veterinarian who's tried to suture up a pad incision, and they'll tell you it rarely ever heals, and it's because of the forces. Every time the pad comes down, it's distracting or pulling the pad tissue apart. It actually can be sutured and healed. It just, you have to address it appropriately. And this is an image that we created a long time ago, because the paw will enter the surface when they're running on the sand, on soft sand or sand. It'll enter the surface when they're running on snow. It doesn't enter the surface on concrete, asphalt, hardwood floors. But the grass surface is an interesting part, because a lot of times the nail will actually go into the surface itself. So the nail is getting it's being held in place while the rest of the paw moves around it. And so it creates all kinds of torsional forces upon the digits, the structures of the digits themselves, which predispose them to injury. And a bigger role is if you're dealing with, in a rehabilitation scenario, it's hard to understand that when a dog's running around the backyard, that distal limb's getting more grip than it is actually on a concrete surface. And so if I wanted to reintroduce activity at a low level to a dog, I'd almost rather have them be on a sidewalk or an asphalt surface as opposed to the yard, so that there's less torsional forces on the limb. And that's just kind of a side thought that may not apply much here, but it shows that this information is applicable to the veterinary field. So I talked about the three orthogonal planes, X, Y, and Z planes, and they're measured across the foot or paw. You can go over a force plate and it will measure these, which is great, but you really don't understand or can't get a feel for the internal dynamics that happens with using a force plate. So we did this back in the early 2000s. I was part of a team where we took the force measurement cables, we took it off the force plate and made it so each paw had a pressure pad. And we took measurements and we led the dog back and forth at a walk. And so we were able to assess the pressures on each pad, which is interesting because I've seen two paw publications talking about toe pressure since then, and they have a little different values than us, and they're not wrong. We're not necessarily wrong. I think it goes back to their capture rate was much lower than ours, and so we were able to capture some of the in-between points that maybe they didn't. So that's the front paw, and then this was the rear paw measurements. So once we identify that stuff, now we can say, okay, what are we going to do to prepare the body to handle these different surfaces? We need to understand that the body as a whole needs to be exercised and conditioned, but just as important is the paw and the paw structures. So often we forget about the musculature and the tendons and ligaments of the distal limb, but they play a major role in what happens to the body as it's moving around, and also to fatigue. As the body fatigues, before the body fatigues, there's a lot of tension and structure and strength to the muscles and tendons, the ligaments, and the bones. As fatigue starts to set in, you start to lose some of the stability that comes from this muscle tendon structures that are as they're tense. And because they get fatigued, and I think Mick saw it, and we talked about it years ago, where at the end of the race in the horse world, where you see these hyperextensions of the joints, not more so than they should be, just greater than the beginning of the race. And so what it is, it's a spring effect. So as the foot comes down, it makes those structures taut. And then as they come off, it's a spring effect. At the end of the race, when they're fatigued, you lose that spring effect. And then the limb is actually the animal is working harder at the end of the race when they are in a fatigue state than they were in a non-fatigue state. So this is one of the things a long time ago, I was brought up a question, could I put together a conditioning program to minimize injuries in our military working dogs? And so we utilized the information that we had learned from the greyhound industry about different surfaces. And we, as part of the conditioning program, the dogs were continually working on different surfaces to prepare not only the body, but the paws and the digits themselves for the rigors of work. And then way back in the 2000s, I had an idea that we could create a way to assess track surface impacts around the surface. And that's where Mick and I had met, because he was doing same things in the horse world. And back to where I said that sometimes we open our mouth and we realize how smart we are not. I said, well, let's just put a box on the track, Mick, and we'll have this little thing. He says, he looked at me he's trying to figure out if I was serious or not. Then when he realized I was, he started laughing, because the force of impact was just throw that box up way out of where there'd be no way we could do that. But I listened to him, and then we learned quite a bit from that. In fact, this was a video of his early system. I think this is in California, where we developed the impact hoof, or he developed it. I watched, and then this is just in slow motion where the hoof comes down and hits the track. This is early stuff. No one had ever done this kind of stuff before. And the thing that's, I think, is really cool about this at the time, I was blown away, is that when the hoof comes down, you not only get the impact at the point of the hoof, but you get a looseness of the surface around it. And maybe Mick can make a comment on this after I get done here in a second. But it really told us that, oh, there's much more than just the impact in a horse race. Then here's was the Rob Stupid box that I was going to put that said the track is safe or not. This ended up being the instrument that was developed, and it worked great until we used it one time on some ice, and that didn't work too good. So I just want to introduce you to some of the basics and some of the things we did or do not know about biomechanics in dogs. Obviously, there's just so much. It's just a huge area. If anybody ever wanted to go into it, because we know a lot, but we don't know a lot more than we know. So this was just an overview. So I'm happy at this point to take any questions or thoughts from any of y'all.
Thanks, Rob. So Rob, how do you condition a dog? Let's say you're well, I mean, I'd use the example of a sled dog, but you could use a bird dog. How is it the variation in the surface? You kind of have to know something about the surfaces they're going to be working on, and then you work within that range. Is that what you would be doing?
I think that's the best way to describe it. I was going to see if there was this one here. So one thing I'll do is I'll identify where the dog's going. Most dogs don't, especially in the middle of the United States, most dogs don't go to the beach. So that for an example, when I was in New Jersey and I dealt with rehabilitation cases that they did go to the beach, I told them they can't go in these soft sand areas because the limb doesn't get traction, and it creates a lot of force action at the lever or the shoulders and hips, which you'll get a lot of muscle strain. And so dogs that have ACL ruptures really have a problem interacting with the sand. Now, that said, if I know that's there, and I have a dog who I'm trying to build up some core structure in a way, and so anybody can do exercises with one dog, but if I got to do it with 5 dogs, 10 dogs, 20 dogs, 100 dogs, That's a different management scenario. That's a different kind of preparation scenario. So if you look at in that middle row on the right, there's some sand with some sand hills in it. So what we did with, and those dogs in the upper left went through all these conditioning programs, is we would have them go over various surfaces, and we would have them, but it was all defined on, okay, if this dog's going to be, say, a Navy dog, this dog will probably engage in some beaches. If this dog is going to be a TSA dog and working at, Cincinnati Airport or whatever, they're only going to interact with hard surfaces, marble, hard type surfaces. They don't necessarily need as much conditioning for the sand as they do. They got to have their distal limb conditioned to the point that it can handle hard impacts most of the time. And so that's more of a strength thing. So, I will take into consideration what the different activities or areas or environments the dog's going to go into from a performance standpoint. From a rehabilitation standpoint, I may take some of these different types of surfaces and say, okay, I wonder if I could use this to help strengthen a certain part or rehabilitate or recondition a certain part of the body. So like if I've got a dog, like a hunting dog, a bird dog that's going to go out in, a field somewhere. It's interesting, Mick, that you bring that up. I mean, where I grew up in Western Kansas, we had real soft fields. And just as an example, between the eastern part of the state and the western part of the state, the dogs that grew up in the western part of the state running around in that soft soil, they would displace their toes as it went in. And their distal flexor muscles or digital muscles got strong. The dogs that came in from Kansas City had mostly been in backyards and or kennel environments. When they came out to the western part of the state, they would come up with a shin splint in the human world, but it's more of a tendonitis. And so even within that same geographical region where we had dogs doing the same thing, the different surfaces could affect the performance. And so you had to prepare for that. And that actually helped me later on when I was preparing dogs to go over to Iraq and Afghanistan, because I knew that might be a potential issue with the surfaces and then the tendonitis in the dog. So we included that as part of the preparatory conditioning program. Is that way too much information, Mick? Sorry.
No, it's spot on. I was sitting here thinking then, of course, about the sled dogs then. The problem is you'd be conditioning them in the summer, which would be an incredible challenge to get them ready for the surfaces that they'd be then competing on, right?
That's exactly right. And then you have, if anybody's ever skied, you got your powder and you got your hard snow and you got dogs breaking snow. I mean, dogs that are specifically the sled dogs up in the north. But there's a lot of dogs that are dry land racing now. I mean, those are all sports. When I was over at Europe this summer, there was rumors that they were going to have at least one dog sport in the Olympics. It was probably going to be ski joring. And, that's where one dog pulls a person on a ski sled in a Winter Olympics. They don't always, if you look at some of those videos of the Iditarod, which is a sled dog race up in Alaska, you'll see a lot of snow running, but you'll see a lot of areas where there's no snow. And so the dog's paws have to be ready for all that. And that's in that middle picture, you'll see they put booties on there. A lot of dogs wear those. It's somewhat of protection from the different types of surfaces that they're going to run on. Bigger thing, because a lot of times in the snow will actually accumulate between the digits and it creates little tears or micro tears in there. And so the booties just help keep that snow from accumulating. If you look at the, let me see where it's at. If you look at that in the middle there, that's a picture of a sled dog paw. That way that hair is, it's important because it helps protect and keep the paw warm. But at the same time, it can accumulate snow and ice, which can actually have a negative effect on the paw.
My office mate here is talking about the fact that he's a standard poodle and he doesn't work well at all with the snow because it balls up. He's got to have the booties on all the time.
That's exactly right. It really is it's something that's, no one brings that up in the veterinary curriculum. But you end up dealing with it at some point or a lot of different ways. Yeah.
It's cool.
So I have a question. I don't know how much this matters, but does the breed and like the genetics of the dog, depending on what they're bred to do, play an impact in how predisposed they are to certain injuries depending on what surface they're on? Because when I'm thinking of like a retriever or a Labrador, like, and they would be swimming more often, then maybe they would be predisposed to injuries on a harder surface versus a softer.
Well, you bring up two things there. One is breed variation, but you're talking about the action or work of a retriever is different than other
Right.
things where they're in the water, right?
Yeah.
So dogs who work in water, you know, their paws may be softer. So when they get out, say they're doing multiple activities where they're in the water getting some ducks, and then they go pheasant hunting in the afternoon, you know, those pads or those paws could be predisposed in the afternoon. So that's a work type of concern that, yes, you're right. And certainly you're not going to see a Yorkie or a Maltese have those kinds of problems because they're never going to be out working like that. So you have this kind of breed difference, but you also have this activity difference as well. But to your point, you know, we always said the working dogs, a lot of times their paw will mimic their prey. And we always realized that the paw of a greyhound, you guys used to have a greyhound laying around there, that their paw
Yes.
looked like the paw of a rabbit. And so they're going through the same things. Now, I see a lot of times pointers have a wider paw, and retrievers certainly have webbing to deal with the swimming. But they all, yes, there certainly is breed differences that can predispose dogs to certain problems than other dogs. Yeah.
Are there any other questions? There's a few people on Zoom that if you have questions, please speak up.
I don't have a question so much as a comment. I just found it really fascinating. You were talking about how it hits the number 5 paw first, which would be the lateral aspect, correct? The outside aspect
Yeah.
of the foot.
And that's actually a controversial statement by me. Go ahead.
Which I find really interesting because I would say 90% of horses hit lateral and then come in and then break over medially, which is what you were showing in your videos. So to me,
Yep.
it's not a controversial statement. To me, it makes perfect sense. So I find that really interesting.
Well, it's a physics thing. And, you know, with those who don't see that, you know, an animal has to do that so it doesn't fall over. You know, when I was testing, actually I tested the troubleshooter yesterday and it worked great. If you look at this there. So that video, it's just a matter of physics, and you're correct, but the force plates don't show that. And the force mats talk about most of the forces are being managed by digits 3 and 4. So I don't know if you can see can you see my mouse?
Yeah.
Okay, so that's digit 1's up here. That's 2, that's 3, that's 4, and that's 5, right? So they're saying that most of the forces are managed here in digits 3 and 4. Well, if you come down here and look what we did, that's not necessarily true, in that this is digit 5, this is digit 3. But if you look at the time of it, and this is measured in Newton meters per meter squared times 10 to the 4th, it's a timing thing. This happened, this digit over here happened before this digit did, and this carries a lot of force as well. So it's distributed across. And then I don't know if I have it. Anyway, there is as the paw comes off, there is a hyperextension. No, anyway, I got a side view of the impact, and at the end of the impact, these toes 3 and 4 are hyperextended, and they do apply a lot of pressure, but it pops off at the end, and that is taken as pressure, and it is. But in reality, I can see where everybody's coming from on this. So I don't, until I can really get this information out in a nice scientific format, I have no way to talk about it really. So
It's fascinating though, tying the physics back to the paw. So thanks. Thank you so much, Rob. That was great talk. Thank you. All right, next week we're going to have Alejandra Blanco, who's going to be talking about her tests with different test surfaces, and Mackenzie's going to talk about sampling rates on acoustic data for horse noises.
And yeah,
Right.
it's not next week, it's the week after. It's
26.
February 16th.
Okay, thank you.
No problem.
February 16th. Thank you. All
Yep.
right. Thank you so much, Rob.